Okay, picking it back up in our discussion of the systems of linear equations, let me put another system up. The first linear equation is 6x plus 2y equals 7. And the second is y equals 2 minus 3x. And so I'm going to look at this with a graph. Actually, let's go straight to our calculator. And I'll clear out the two that I had in here, and we'll put, so the first one, we need to rearrange this so that it's in that solve for y. So let me write it again over here. 6x plus 2y equals 7. So I want to isolate the y, so I don't want this 6x over here, so I'm going to subtract it from both sides. And so that will leave me with 2y equals 7 minus 6x. Lastly, I don't need this coefficient in front of the y, so I'm going to divide everything by 2. So every single term gets divided by 2. And that will leave me with y equals 7 over 2 is 7 halves, or if you prefer a decimal, 3.5. And 6 over 2 is 3, but I have subtraction here, so this is minus 3x. And we can leave it like this and say that for our first equation, we have 3.5 minus 3x. And the second equation was already solved for y, so I can just put this as 2 minus 3x. And let's try graphing that. So I'm not seeing a point where these two lines intersect. Now it could be that they intersect at a point that's outside of my viewing window. Let's see if I just change this to go from negative 100 to positive 100 with increments of 10 marked on my axis. And we'll do the same for the y minimum, y maximum, and the tick marks. And look again. And this time the lines are so close together that I can't even see if they're distinct from one another or if they intersect. So what I want to point out here, so I'm actually going to take that window back down a little bit. So negative 10 to 10, and we'll use tick marks of 1, negative 10 to 10 with tick marks of 1. Where you can see it, graph. So now I can see that we do have two distinct lines, and it looks to me like these lines are parallel. So in order to confirm this, I want to look at the slopes. So the slope is the multiple of x. In this case, it's negative 3. And notice that that was the slope in this equation as well. They have the same slope, but they have different y-intercepts. So for this line, the slope is negative 3, and the y-intercept is 2. And for this equation, the slope is negative 3, but the y-intercept is 3.5. The fact that they have the same slope, the same tilt, tells me that these lines are parallel. And so they do not intersect. So the solution set is the empty set. And the symbol that we use for that looks like a 0 with a line through it. All right, let's look at another option. So our system consists of the equations 9x minus 3y equals 12 and y equals 3x minus 4. That's what I'm going to actually just start out by hand, and then we'll look at it in the calculator. The first one, or actually the second one here, I'm going to do that one first because it's the easier. It's in slope-intercept form. I know that this crosses my y-axis at negative 4. That's the point 0, negative 4. That's because the y-intercept is negative 4. And there's a slope of 3, a rise over 1, 3 over 1. So it goes up 3 and over 1. And I'll just connect those 2 points. And this is y equals 3x minus 4. The second one, I want to make a table and include some x and y values. Let's say that x equals -1. Actually, let's do -2. Just make the calculation easier. So 9 times -2 minus 3y equals 12. This would be -18 minus 3y equals 12. So if I add 18 to both sides, I'll end up with -3y equals 12 plus 18 is 30. Let's see, -3 times some number equals positive 30. Well, I know that 3 times 10 is 30. If I want this to be a positive, I need to multiply a negative times a negative. So y would have to equal -10. So let's see, y is -10 when x is -2. So that's one ordered pair. We just put a line here. What happens when x is 0? So when x is 0, this term, the first term, basically 9 times 0 is 0. So I end up with the statement -3y equals 12. So again, I'm thinking of a number that I multiply by -3 to get 12. That would be -4. And what if I use the value 1? So 9 times 1 is 9. If I subtract 9 from both sides, I'll end up with -3y equals 12 minus 9, which is 3. In this case, y equals -1. So I end up with the point 1, -1, working from the bottom up, 1, -1. That was a point that was already on this graph as well, 1, -1. So they have that point in common. They also have the point 0, 4 in common. So 2 points are enough to determine a line. So it looks like the line determined by 9x minus 3y equals 12 is the same line as y equals 3x minus 4. And in fact, those are the exact same line. So the solution set for this system consists of all ordered pairs in the form x comma y such that, so this little bar is read such that. And then you could write in either of these, such that 9x minus 3y equals 12. So pick one, and then that's what you would write after the bar. The solution set for this system is all ordered pairs in the form x comma y, such that 9 times x minus 3 times y equals 12. So there are infinitely many points that satisfy both of these equations. You could pick any ordered pair that's on this line and plug the x value in and the y value in, and it would make this statement true and this statement true.